In this video, we are going to discuss few problems on Cauchy's residue theorem. First problem, evaluate integral over c cos pi z square by z minus 1 into z minus 2 dz, where c is the circle, mod z is equal to 3. The given problem is cos pi z square divided by z minus 1 into z minus 2 into dz. Here, using Cauchy residue theorem, we are going to find the value for this one without integrate with respect to z. In step 1, find the poles. Okay. Step 1, find the poles. Equate the denominator term to 0. Z minus 1 into z minus 2 equal to 0. Then we can write z is equal to 1 and 2. These are the poles. Each and every problem, first we have to find the poles. And then we have to check the order. Order means here in this problem the power value is here 1. If the power value is 1 means we can say that these are the simple poles. Now we can write here z is equal to 1 and 2 are simple poles. If the power value is 1 means we can say that they are called simple poles. And then draw the diagram for the given image. Modulus of z is equal to 3. Modulus of z is equal to 3 means z is equal to, we can write x plus iy equal to 3. And then remove this modulus, root of x square plus y square is equal to 3. And then taking square root on both sides, getting x square plus y square is equal to 3 square, which is in the form of circle. We know that the general equation of the circle, which is x minus a whole square plus y minus b whole square is equal to r square. Here a and b are 0 and 0, which means center of the circle is 0, 0 and radius will be 3. Now we can draw the diagram. X-axis, y-axis, and then center here 0, 0, radius 3. Okay. Modulus of z is equal to 3 means center of the circle is 0, 0 and radius is 3. Okay. Now here 1 and 2 are the poles, simple poles. Here these both poles are lies inside the given image, because 1 here will come 1, 2. Both are lies inside the given image. We can write here z is equal to 1 and 2 are simple poles and also lies inside the circle. Modulus of z is equal to 3. Now we can use the residue formula to find the residue for each pole. Okay, in step 1 find the poles and then find the residue for each pole. Because we are going to write the residue formula, simple pole residue formula. Okay, r is equal to limit z tends to z0, z minus z0 into f of z. You should remember this formula. Using this formula we can find the residue for simple pole. Okay, in this problem we are having two poles. First we can take here z is equal to 1. First we can find the residue for this z1. Now we can take r1 is equal to limit z tends to z0. Z0 is here 1 into z minus z0. Z0 is here 1 into f of z. F of z is the whole function. This is f of z. The whole function will be f of z here. Substitute here cos pi z square divided by z minus 1 into z minus 2. Okay. Now we can remove these two terms here and then apply z tends to 1 here. Cos pi into z square. Z1 means 1 square, which is 1, and then substitute here z is equal to 1. 1 minus 2. Value of cos pi is minus 1 divided by 1 minus 2 is minus 1 equal to 1. R1 value is 1. In the similar way we can find R2. Then take z is equal to, what is our other pole? 2. Now find the residue for z is equal to 2. Z tends to z0. Z0 is here 2 into z minus z0. Z0 is 2 into f of z. F of z is cos pi z square by z minus 1 into z minus 2. Now we can remove z minus 2 into z minus 2 and then substitute here z is equal to 2, which is cos pi into z square. 2 square, which is 4, 4 pi divided by 2 minus 1. The value of cos 4 pi is 1 by 2 minus 1 is 1, 1. Okay, now we are getting R1 and R2. Now using Cauchy residue theorem formula, Cauchy's residue theorem formula, we can write the final answer. The statement of Cauchy's residue theorem is integral over c f of z dz is equal to 2 pi I into r1 plus r2 plus etc., which means sum of the residues. Okay, in this problem we are having two residues, cos pi z square by z minus 1 into z minus 2 dz is equal to, we can write 2 pi a into sum of the residues r1 plus r2. We are having only two residues here. Substitute here 2 pi a into r1 value is 1, r1 is 1 and r2 also 1. Substitute here 1 plus 1 equal to 1 plus 1, 2. 2 into 2 pi a will be 4 pi a, which is the required answer. Okay. In step 1, find the poles. In this problem, we are getting two poles and then check with the given image whether it is lies inside the given image or lies outside the image. In this problem, both poles are lies inside the given image. That's why using the simple pole residue formula, we can find the residue for both poles R1 and R2, and then with the help of Cauchy's residue theorem, we can write the final answer. Okay. Next problem. Evaluate. Integral over c z square by z minus 1 whole squared into z plus 1 into dz, where c is the circle. First one is modulus of z is equal to 1 by 2 and modulus of z is equal to 2. In step 1, find the poles. The given problem is z square by z minus 1 whole squared into z plus 1 into dz. Equate the denominator term to 0. Z minus 1 whole squared into z plus 1 equal to 0. Okay, now we can write z is equal to 1 and minus 1. Okay, here z is equal to minus 1 is a simple pole. See, look at this, here power value is 1, which means we can write z is equal to minus 1 is a simple pole. And z is equal to 1 is a pole of order 2, because here power value is 2, that's why we are writing here order is 2. In case if we have here 3 means we have to write z is equal to 1 is a pole of order 3. Okay, step 1, find the poles, and then step 2, draw the diagram for the given image. First image is modulus of z is equal to 1 by 2. We know that z is equal to, we can write x plus iy equal to 1 by 2, and then remove this modulus. Root of x square plus y square is equal to 1 by 2. Taking square root, squaring on both sides, we get x square plus y square is equal to 1 by 2 whole square, which is in the form of circle. We know that the general equation of the circle, which is x minus a whole square plus y minus b whole square is equal to r square. Here A and B are 0, which means center of the circle is 0, 0 and radius is 1 by 2. Okay, and then draw the circle, x-axis, y-axis, center here 0, 0, radius is 1 by 2. Okay, now in this problem we are having two poles. First one is -1 and another one is -1 and 1. We are having two poles. If we check with this diagram, both poles are lies outside the image only. Here +1 will come. Okay, +1, -1 this side will come. Both poles are lies outside the image. In this case, using Cauchy integral theorem, we can write the final solution. Z1 and -1 are lies outside the outside the circle, modulus of z is equal to 1 by 2. We know that the statement of Cauchy integral theorem, integral over C f of z dz is equal to 0. Now we can write integral over C z square by z minus 1 whole squared into z plus 1 dz is equal to 0. Okay, and then our second image is modulus of z is equal to 2. Here substitute z is equal to x plus iy equal to 2, and then remove this modulus. We can write root of x square plus y square is equal to 2. Squaring on both sides we are getting x square plus y square is equal to 2 square. Here the center of the circle is 0, 0 and radius will be 2. Okay, and then draw the diagram, x-axis, y-axis, and radius is 2, circle. Okay, center origin 0, 0 and radius is 2. In this problem we are having two poles, which is -1 and +1. Both are lies inside the image only. Inside the given image, modulus of z is equal to 2. Here 1 will come, here -1 will come. -1 and 1 are lies inside the circle, modulus of z is equal to 2. Now we are going to find the residue for -1 and +1. Here z is equal to -1 is a simple pole already, because power value is 1. Here z is equal to -1 is a simple pole, and z is equal to +1 is a pole of order 2. Okay, now we have to find the residue. First pole is simple pole only. We know that the simple pole residue formula, which is r is equal to limit z tends to z0 into z minus z0 into f of z. Simple pole residue formula, you should remember. Okay, now take z is equal to -1, then calculate r1. Z is limit z tends to -1, z minus of -1 will be +1 into f of z. The given f of z is z square by z minus 1 whole squared into z plus 1. Okay, now we can remove these two terms, and then here apply z tends to -1, which is -1 whole squared by -1 whole square. Okay, which is equal to 1 by -2 square will be 4. R1 is 1 by 4. In the similar way, we have to find the residue for z is equal to 1. Okay, next we can take z is equal to 1, but here z is equal to 1 is a pole of order 2. Okay, we know that the general formula to find the residue for pole of order 2, which is r is equal to limit z tends to z0 1 by n minus 1 factorial into d power n minus 1 by dz power n minus 1 into z minus z naught power n into f of z. You should remember the nth derivative residue formula. Okay, if you know this one, you can write for any order. Okay, here n is, what is our order? N is 2. Okay, order is 2 here. Substitute in this formula, n is equal to 2. Limit z tends to z naught, 1 by 2 minus 1 factorial is 1 factorial, d power 2 minus 1 is d power 1 by dz power 1 into z minus z naught power 1 power 2, because n is equal to 2 into f of z. This is the second derivative residue formula. Okay, you should remember. If you know the nth derivative formula, you can write for any order. Now we can take z is equal to 1, which means z naught is 1. R2 is equal to limit z tends to 1. 1 by 1 factorial is 1 only. D by dz into z minus 1 whole squared into f of z. The given f of z is z square by z minus 1 whole squared into z plus 1. Okay. Now we can remove z minus 1 whole square here, these two terms, and then getting z limit z tends to 1 d by dz of z square by z plus 1. D by dz of z square by z plus 1 means we have to differentiate with respect to z. Before we apply the limits, we have to differentiate this one. Apply here u by v rule, because in the numerator z term is there and also in the denominator also z term is there. Z plus 1 whole square, z plus 1 into 2z. Okay, u by v rule. Okay, u into v dash minus v into u dash. 2z minus z square into u into v dash. V dash means z plus 1. Differentiation of v is 1. Okay, now you no need to simplify this one. We can apply the limits here directly. Z tends to 1 means substitute here z is equal to 1. 1 plus 1 into 2 minus 1 by 1 plus 1 whole square. 1 plus 1 2, 2 into 2 4, 4 minus 1 is 3, 3 divided by 1 plus 1 is 2, 2 square is 4. Or R2 value is 3 by 4. Okay, now substitute these two values, that is R1 and R2, in Cauchy residue theorem. We know that the residue theorem statement, Cauchy's residue theorem, integral over C f of z dz is equal to 2 pi a into sum of the residues. In this problem we are having two residues, that's why we can write here only R1 plus R2. Integral over C, the given f of z is here z square by z minus 1 whole squared into z plus 1 into dz is equal to 2 pi a into R1 plus R2. R1 is here 1 by 4 and R2 is 3 by 4. Substitute here 1 by 4 plus 3 by 4. If we simplify this one, we will get the required answer. 1 by 4 plus 3 by 4 will be, both the denominator values are same. We can add the numerator here, which is 4 by 4. You know this one. Answer is 2 pi I. That's it.